Okay, let's unpack this. Today, we are looking at a piece of hardware that, honestly, it looks like something you'd find forgotten in a drawer full of cables.
Yeah, definitely. It's small, unassuming. The name alone, the Key Digital KD-CCXR200.
Right. Only an engineer could love that name.
But despite that, that utilitarian look, this little box is doing some serious heavy lifting in the AV integration world.
I want to start with the physical design, because it really threw me. It's got a 3.5 millimeter connector on one end,
Mm-hmm.
the standard headphone jack size, but I assume if I plug this into my phone, nothing's going to happen, right?
Right. And please don't try that. It's not for audio at all. This device is a specialized translator.
A translator.
Yeah, it's built to bridge the gap between Key Digital's control ecosystem and, well, the physical high-voltage world. It takes a software command and turns it into a physical switch flip.
So it's a bridge, but here's where I get stuck. It's basically a relay, right?
Right.
And I saw the price tag. It's around $350 for a dongle.
That is the $350 question, isn't it?
Why wouldn't an integrator just, hack together a generic 12-volt relay for a fraction of that?
And you could, but you aren't just paying for the hardware, you're paying for the handshake. This thing is designed to work specifically with their compass control ecosystem.
Yeah, okay.
It plugs into a very specific port called the MPC35 on their matrix switchers.
So it's the classic walled garden approach. You pay the premium so you don't have to get out the soldering iron.
Exactly. The value proposition is all about reliability. The integrator knows that when the software sends a command, this box will interpret that voltage trigger correctly. Every single time.
How does it actually trigger?
It uses what's called a voltage trigger mode.
Mm-hmm.
So when the matrix switcher sends 12 volts down that 3.5 millimeter line, the KD-CCXR200 switches from normally open to contact closed.
Walk me through that logic for a second. Normally open.
Think of it like a drawbridge that's always up. No traffic, or in this case, electricity it can get across. That's its default, normally open state.
Right.
The moment you tap screen down on your control panel, the matrix shoots 12 volts into this dongle. The drawbridge lowers, the circuit completes, and boom, your motorized screen starts coming down.
So it's letting a tiny low-voltage data signal control some real high-voltage brute force.
Precisely. And speaking of brute force, that's where this thing is kind of surprising. It's rated for up to 250 volts at 2 amps.
Wow.
That is legitimate infrastructure power, all being handled by a device that fits in the palm of your hand.
I was looking at the specs, and I kept searching for the power input. I couldn't find a barrel plug, no USB port. How is this thing even powered?
That's one of the really clever bits about it, but it's also one of its biggest constraints.
Oh.
It has no external power supply. It's parasitic. It just sips what little power it needs right from the connection to the matrix switcher.
That sounds great for keeping racks tidy, but physics usually demands a trade-off somewhere.
And the trade-off is distance. You are on a very, very short leash. The input side, that 3.5 millimeter cable, it cannot be longer than 10 feet.
10 feet. That's nothing in a commercial install. If my motorized blinds are across the conference hall, this seems kind of useless.
Well, see, only the trigger has to be that close. The brain has to sit near the switcher. The output side, where you connect the actual high-voltage gear with CT5E or CT6 cable, that can run up to 100 feet.
Oh, okay, that makes a lot more sense. The translator stays in the rack, but the muscle can be halfway across the building.
You got it.
So paint the picture for me. When does an integrator actually reach for this specific tool?
Imagine you're retrofitting an older building, maybe a historic one. You have these heavy, old-school motorized projection screens or lighting rigs that just run on simple contact closures.
Right, they're dumb hardware. No Wi-Fi, no smart features.
Exactly, they're just dumb hardware. This little device lets you drag them into the 21st century. You can have a sleek, modern touch panel, seamlessly controlling a motor that's 20 years old. It makes the complex interaction between digital code and mechanical action totally invisible to the user.
That is a solid use case. It's interesting to think about how much of our smart world is really just sophisticated software, triggering very old-school mechanics.
It really is. We get obsessed with the interface, the shiny glass screens, the elegant code. But at the end of the day, if you want a physical object to move, something, somewhere, has to physically close a circuit.
And this is just a very reliable way to do that.
It's just a very expensive, very reliable finger flipping that switch.
A $350 digital finger. I like that. It's a niche tool for sure, but I can see why it's essential when you're locked into that ecosystem.
It's always a pleasure to get under the hood of this stuff.
Well, that's it for this deep dive. Next time you press a button and a screen silently lowers from the ceiling, just remember, there might be a little 12-volt drawbridge somewhere making it all happen. Catch you next time.